Hello, Professor. I'm here to give you my presentation for the math project. My topic was on population trends in New Jersey from the years 1930 to 2010. I said at some points it seems like an exponential increase in the population trend, but there are places where it almost levels out. The function that best fits my regression was a quartic regression. I chose this topic because I have always been fascinated by how species multiply. It's interesting to see how immigration and similar things affect the rate of a population. My data ranges from the years of 1930 all the way up until 2010. On my x-axis, I have time in years by the decade, and on my y-axis, I have population in millions. So my first population is 4.0, so that's about 4 million people. I figured out the slope of my line. The slope of my line, which was the y2 minus y1 over x2 minus x1. I took 8.8 minus 4.0 million over 2010 minus 1930. That gave me about an increase of 0.06 million people per year. The regressions I used, like I said, were the quartic regression because that's the best one that fit. And then I also used a normal linear regression. I found the instantaneous rate of change at x equals 1970, and that equaled 0.0765. I found the limits for my combined regression, and my limit as x approached infinity, my regression approached infinity as well, and as my x value approached negative infinity, my regression equation approached negative infinity. The derivatives of my exponential regression and linear regression are, so I have the years 1930 all the way up to 2010, and I'll just give you a few ones just for the first couple. For 1930, my derivative for the quartic regression was, the exponential regression was 0.0436. For 1940, it was 0.0486. For 1950, it was 0.0536. And 1960, it was 0.0604. And for 1970, it was 0.0666. And for my linear regression, I'll do the same few. For my linear regression for 1930, it was 0.0662. For 1940, it was 0.0669. For 1950, it was 0.0655. For 1960, it was 0.0652. And for 1970, it was 0.0656. I also noted that the sign regression did not work with my data that I used. I also did the Newton's method and rate of change here, and I did this for the cubic regression like we did on our worksheet. So use the equation x minus function of y1 divided by the derivative at y1, and then store x. So for my first three iterations, I got about 652.486. Second one was 434.596. And for my third iteration, I got 507.392. My zero eventually came out to about 489.165. Error. I'm not sure if I did this right because it seems a little ridiculous, but since my data was considered in years by the decade, my error will be a product of my derivative times plus or minus 5. So I got error of negative 557.271, which, like I said, seems a little out there, so I'm not really sure. And my maximums and minimums, for the function, there was a maximum at x equals 2008 and y equals 8.65. There was a minimum at x equals 1909, y equals 3.18. My function was increasing from 1909 until 2008, Then 2008, it started decreasing again. And you can't see this, but I did the area under the quartic regression, and the value that I got was 520.34105. I believe that's all I really needed to do for my product, but I hope that suffices as a presentation. So